Okay, I think we will start. Let the others join. So last time we started with this first topic, that is low cost automation, or we have yet to start. Kaustubh, did we start last time or not? Kaustubh is there.
No, sir. I don't think so. We didn't start.
Okay, so we will start firstly with this low cost automation. Okay, so the reason to start with this low cost automation, as I told you earlier, this subject, if you see the content, almost 80% of the content is belonging to electrical and electronics part. So it becomes very difficult for you people to understand. Always remember there is some constraint. Yes, Arnav, your mic is on. Arnav,
We have done
so
this, the first few slides we have done last time.
Yes, the starting four slides are done. Like you did till gates. Control wall was some part is done.
अच्छा ओके ठीक है ठीक है ओके so just remember this one particular thing, the reason why we start with this low cost automation, just to make you familiar that something is there pertaining to mechanical, and that is something which we can start with. So as you people told me, I think we might have finished up to this much direction control wall. So this is something I think we can start from here. That is two-way control wall. So two-way directional. So we might have discussed last time there are different types of walls. Like some walls are directional walls, some walls are regulator walls, some wall are relief walls. So these directional control walls are used quite extensively in low cost automation circuit. And without understanding these walls, it is very difficult to understand the functioning of these circuits. So suppose for example now two-way wall. Two-way means two ports will be there, as well as two positions will be there for that wall. It means on and off these two positions it can have. And another thing is that two ports through which you can connect this wall. So now this two-way directional wall consists of two ports connected to each other with the passages which are connected and disconnected. In one extreme spool position, port A is open to port B. The flow path through the wall is open. In on the other extreme condition or position, the large diameter of the spool closes the path between A and B. Flow path is blocked. Now, what this all explanation means here, it is indicated in the diagram. So this is what the conditions are there for two-way two-port wall. So that is the first symbol on the top. It indicates about the normally open position. The symbol which is there at the bottom is called normally closed position. You can just understand with the movement of the piston, sometimes the ports will get open, sometimes the ports will get blocked. Then here is the three-way wall. So this three-way wall, now you will have to understand the symbols correctly. Right now, the symbols you are observing, it should be drawn in the similar way. There should not be any single change in the symbol. As I told you, all these symbols are as per IS 5050. So if you make any changes, then obviously you're not following the standards. That is first thing. Second thing is it means something else. Slight change in the symbol means some direction may get changed, some component may get changed. So that is very difficult to justify later on. And actually your circuit is wrong. The outcome that you are expecting will not be there. So symbols should be drawn very correctly. Earlier, when actually um, you people used to be into the campus, that time I used to draw, ask you to draw all these symbols firstly in your notebook, and whatever circuits are there, you used to draw it. People, students used to draw it. So a lot of practice was there. So these problems were less. Last batch also I realized those who appeared for this, that symbols they were not able to draw correctly. All these limitations are there right now. But if you slightly make some practice, so it will be okay. So this three-way directional wall, you can see now right left symbol. So due to the position of the piston P, that is inlet port is blocked. You cannot allow air to pass through that. Then so if that is the case, then A is connected to exhaust. A is what? A is the port which is normally connected to the actuator, and mostly it is single acting cylinder or double acting cylinder. So these positions are there. Now, if this is the condition, then how will you indicate into the symbol? So that is the symbol drawn over here. That is reverse arrow and one T. T shape means what? Shut off position. So which position is shut off? P. That is inlet is shut off, and it is allowed to pass through exhaust. Then there is another diagram on the right side. You can see exhaust is blocked. So in that case, you can say P is connected to A, that is inlet flow is there. Through A, that flow you are giving it to actuator, but exhaust is not allowed. So air is trapped at that point of time. If this is the condition prevail, then how we will indicate with the symbol? So that is indicated at the bottom side. That is P is connected to A, and then exhaust is shown as shut off. So this is how symbols you need to understand and indicate different conditions. Okay, so you might have understood this symbol. Now this is another wall, four-way directional control wall. Now for this four-way directional control wall, we will first try to understand how different ports are there and what is the position of the piston over there. You can right now find out there is pressure passage indicated over there. It means pressure inlet is allowed to flow. With that, it will allow to get through A, passage A. Passage A means what? It is connected to actuator, cylinder, any of the cylinder. So through A, it is connected to cylinder. Once cylinder gets actuated, the air trapped at the other end of the cylinder is going to exhaust. So it will be exhausting through passage B and then to the exhaust passage. So this is how normal functioning is there for this kind of symbol. Can you try to draw the symbol for this four-way directional controller? Right now you are witnessing a cross-sectional feature for this four-way directional wall. Can you just, I will just give you 1 or 2 minutes. You can just try for the symbol by observing the constructional position. Because if you can draw this symbol correctly, then a lot of other things will get resolved automatically. Because later on, a lot of complicated circuits are there. I already told you people, if you are able to download that software, it will be helpful for you. You can practice as many circuits you want. That is fluid sim. I will again type for your reference again. So you can now anyway, maybe next week or after that. So we will be having practicals mostly on Wednesday. So only one day we will be having instead of having into four batches. So that we will be conducting on single day because software part is also involved over there. So Wednesday, if I think we are able to cover some syllabus, then we can do it on next Wednesday or after that next day, next Wednesday. So I hope you might have tried about it. So I will show you the actual symbol. By observing this symbol, you will come to know what mistakes are possible and how to interpret the actual constructional feature of the wall. So this is now indicating the symbol along with the constructional feature. So in the first position, we can understand P is connected to A. So arrow upward is there. Then there is another possibility that exhaust is connected through B. So B is connected to exhaust. So reverse arrow is indicated. So simplest way to indicate this symbol is written over here. But if spool position means what? The rod and piston assembly. If that spool position changes due to the pressure application, so piston moves out to the extreme left condition, and in that case, you can see the P gets connected to B, and A is connected to exhaust. One dotted line is indicated; it is showing a hidden part of it. So this is how A can be connected to exhaust. So this is what happens over there. So P is connected to B, A is connected to exhaust. All of you have understood this symbol. This is perhaps one of the most critical part. And if some of you have been able to draw it on your own, there is nothing like that. Yes, understood, Rahil. Understood, Sarang.
Yes, sir.
Okay, Jai Singh. No, Jaivir Singh. Okay.
Sir, I am Rahil and I understood. I
Okay.
wrote it in chat actually when you asked.
Yes, yes. Rahil, what did you say?
Sir, when you asked that if I understood or not, at that time I wrote it in chat, but you didn't check.
Okay, 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 fine. So this was about four-way wall. Now five-port wall. Once you understand these symbols, see later on, anyway, this constructional part will not be anymore there. So you will have to only imagine the position of the piston and entire spool assembly. If you're not able to imagine it correctly, it is very difficult to draw the circuits. Now in the present case, this is called as five-ported four-way wall. So can anybody just apply your logic, and can anybody tell why it is called four-way wall? Since the ports are five.
Now the port is blocked, sir.
No, no, the blocked is okay.
So at a time, only four will be operational.
Yes, yes, four will be operational, but more importantly, one of the exhaust will be closed at any point of time. Whatever is the spool, it may be at the extreme right, it may be at the extreme left piston position. In any of these conditions, one of the exhaust will be closed. So even if it is five-ported wall, it is four-way wall. So in that case, how to predict in terms of symbol that is indicated over here? That is obviously if exhaust one in the current diagram, it is shut off condition. P is connected to A, then B is connected to exhaust 2. But the other square indicates the position which is possible in the next situation, that is when spool moves to the extreme left condition. Piston is at the extreme left condition. In that case, this is will be the scenario, that is P will be connected to B, A will be connected to exhaust 1, and that time exhaust 2 will be shut off. So this is how you will have to indicate two possible situations in two squares. So this is how you will have to indicate the symbol. Symbol should consist of all the necessary things, so that the people can understand what are the actuating means, how the operational features are there for this direction control valve. So apart from this, that is indicating two switching position. On the left side there is left actuator indicated, and on the right side there is right actuator. What are these actuator? Actuator means the actuating means. So from the left there is inbuilt spring in the wall, which will enable further stroke, and on the right side it is by with this solenoid valve. You might be knowing about the purpose of the solenoid. It is electrically activated. So we can say this particular wall is an example of electro-pneumatic component, because some of the components are actuated electrically, some of the components are actuated pneumatically sometimes. So when it comes to left actuator, it will be this in inbuilt spring. On the right side, it will be solenoid wall. So this is how you can represent any particular wall. These are the position boxes. A two position wall is shown by two boxes. Then a three position wall is shown by three walls. So this is what it is indicated. Now what is these three positions? Anybody can comment on this. What can be the third possible position? No. What third? Okay. Any other? Okay, to some extent you are right. Complete shut off when actually you will be indicating this position, third position. In our normal terms, we can call it as neutral position. So it is neither on, neither off. So in that case, all the positions which are indicated in this square or in this position, all are in shut off condition. Nothing will happen over there. So that kind of third position be applied in real-time conditions with industry. So from that point of view, you will have to think. So now there is a wall ports. Every wall port which appears on the outside of the wall is supposed to be shown on the symbol, but the ports are shown on only one of the boxes. The box that represents the flow paths that exist at the start of machine cycle. Now, what does it mean? See, all the symbols are drawn over here and they are indicating vertical lines over there. That is a 2-position 2-port wall, and then a 2-position 3-port wall and 3-position 4-port wall. Now you can observe in the first diagram itself, only the vertical lines are indicated in one of the squares. Other square is left blank. This is something which you will have to keep it in mind. Most of the times students are committing these mistakes. They are actually indicating connections in both the squares at the same time. This is not possible. At the same time, you can either have on position, off position, any of this. You cannot have at the same time on position as well as off position. On off means at the same time you cannot have two positions. Like earlier we have seen is P is connected to A. So P is connected to A is okay, but P cannot get connected to A as well as B at the same time. So that condition we cannot show. Whatever is the first starting point that we are referring to, accordingly these symbols can be drawn. So with that reference, you can read out that first diagram belongs to 2-position 2-port wall. Second diagram belongs to 2-position 3-port wall, and third diagram is 3-position 4-port wall. So these walls are there. Okay, I hope you might have understood these symbols. Later on,
Yes,
we
sir.
will be okay. We will be drawing all these symbols. This is the diagram now indicating some flow paths. Each box contains a group of lines that represent the flow paths the wall provides when it is in that position. If a port is blocked, we show that by symbol T. If two ports are connected and air can flow, it is shown by a line drawn between the two ports. And obviously, if ports are not connected, then it is a shut off position, and shut off position is indicated on the left square. That is, two lines are drawn but with the parallel plates, like capacitor kind of structure is there. So this is the another way to indicate the symbols. Now we can read out the symbols like this. First example is indicated. So that is at the start of the cycle, the flow path from port 1 to 2 is blocked. When the wall shifts, the flow is from 1 to 2. Okay, so two positions are indicated. In the first position, it is block condition or shut off condition. In the second port, it is allowed to pass through. That is, airflow is possible, 1 to 2. Then in example 2, another symbol is drawn. Now it means at the start of the cycle, the flow path from port 1 to port 2 is blocked. And when the valve shifts, port 1 is opened to port 2. I will later on show you a lot of other videos, also simulation, so that you will understand what right now description we are reading. But during some part of the cycle, air flows from port 1 to port 2. And during another part of the cycle, air flows from port 2 to port 1. What does this mean? First part is okay, that is at the start it is blocked. But what does it mean during some part of cycle? 1 to 2 and 2 to 1 are simultaneously open. So it only means that when you are completing a cycle at that time, air is completely, it is not exhaust, it is not supplied. So completion is not there. Some mixing is there, some inlet, sometimes in stroke, out stroke, they overlap with each other. So it happens, and that is how indicated over there. These are the critical symbols now. You can just observe this symbol for the timing. Ayush is there. Ayush, Abhishek, Adesh.
Yes, sir.
Ayush is there. Ayush Patel. Aditya Singh, Amar, Aniket,
Yes, sir.
Anjali,
Yes, sir. Yes, sir.
Amar. Amar is there or not? Amar is there or Ayush? No reply. Okay, we will wait them till the attendance is over. After that, we will remove them. Aniket is there. Arya,
Yes, sir.
Yes, sir.
Ashutosh, Atharva, Bhagyashree, Bhushan,
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Chaitanya, Gufran,
Yes, sir.
This is Amma. Yes, sir.
Gurpreet, Gurprasad,
Yes, sir.
Harsh, Mevda,
Sir.
Harshal, Hemant,
Yes, sir.
Ritik,
Yes, sir. Yes.
Jay, Jayant,
Yes, sir. Yes, sir.
Yes, sir. Yes, sir, Jayan.
Javeer Singh, Kritik, Kaustu.
Yes, sir. Yes, sir.
Hello, sir.
Hmm?
Sir, I am present.
Yes, Amar, what happened?
Sir, my mic, actually my Chrome browser, I have kept the mic on disable always, so I had to enable it
Okay,
so that it doesn't accidentally. That's why.
okay.
Sir,
Yes.
sir, for Fluid Sim, sir, can you share the link so that we can download the same version, everyone?
No, no. See, it depends. There is lot of variety. There are at least 3 to 4 versions possible. Now, whatever is adaptable to your system, Windows, some of you may be having 7, some of you may be having 10. So it is okay. Whatever version you will be able to download, there are no much deviations into that. So don't worry about it. Just make sure that you are able to download. Now, what is happening over here with me is that I am last time I downloaded it, then obviously it was 30-day trial versions. Now it is not allowing me because the registrations are there for only one time. So some issues that I am facing. So I don't want you people to face any such issue. If you are able to download any version, that is okay. Mostly you can go for this TwitSim 5.6, and that is quite easily you can download it. The file is very small and simplest circuit you can have over there.
Okay, sir. Okay, sir.
Mhm. Okay. So Karthik is there, Kaustubh, Kaveri,
Yes, sir.
Yes, sir.
Manas,
Yes, sir.
Monil, Monil. Mohammad Saif Ansari,
Yes, sir.
Yes, sir.
Mrityunjay, Munish, Neha,
Yes, sir.
Yes, sir.
Neha Kurian, Nikhil, Nishant,
Yes, sir.
Nivrutti, Omkar, Prajakta,
Yes, sir.
Present, sir.
Pratik, Rahul,
Present, sir.
Sir.
Raju,
Present, sir.
Rakesh, Ravi Desai, Ravi Parmar,
Present, sir.
Ryan,
Yes, sir.
Ritvik,
Yes,
Sagar,
sir. Present.
Sakshi, Saloni,
Yes, sir.
Yes, sir.
Present.
Sanat, Sarang, Sarthak.
Yes, sir.
Yes, sir.
Sarthak, you people, how long you will be there in the darkness? So that darkness is there all the time. Make sure that you are no more with the darkness. Survesh, Shivpriya,
Yes, sir.
Yes, sir.
Shlok, Shreyas,
Yes, sir.
Shrikant, Shruti, Shubham,
Yes, sir.
Yes, sir.
Swangi, Suresh,
Yes, sir.
Shruti, Suraj, Tanmay, Tejas,
Yes, sir.
Yes,
Present.
Yes,
sir.
sir.
Yes, sir.
Varun and Yash.
Yes, sir.
So you might have observed right now these symbols. So this is now very important. The symbols right now you are observing same symbols you will have to draw when we will be actually going for studying the circuits. So here at the first, we will start from the left top. That is first symbol, two-way blocked at the start. Alternative way is that you can also say it is two-way normally closed wall position. So it is obvious we have studied last time also, earlier PPT, that at the start of the cycle it is shut off, air is not allowed to pass through. So in that case it is called normally closed position. When you change the position of the piston, in that case A can be connected to P, so it gets started later on. Then the left second position, three-way blocked at the start. Three-way blocked at the start means what? You can see shut off position, T position and reverse arrow. That reverse arrow indicates the exhaust. Then the next from the third uh, left position, two inlet selector. So two inlet selector means there are two inlets possible and you will have to decide which one you want to apply pressure. These are different variations. Actually, a lot of other things are also possible. Was some common symbols we are much concerned with. That is next is four-way, four-port single inlet. So what does it mean? So that is this wall. You can say simple connections. It is similar to what we have seen in the construction feature of the four-port wall. There is four-way, five-port, dual pressure, common exhaust wall. So common exhaust is also possible. Some of the circuits we will be trying with the common exhaust. Then there is a two-way open at the start of the cycle. That is two-way normally open position. You can also call it N oblique O. This is how you can indicate an N oblique C, normally closed position. Then from the right, second diagram, three-way open at the start of the cycle. So P is connected to A in this regard, and then it is considered to be a start. Distributor, this distributor is a slightly different thing to understand. Distributor means what? Uh, Later on in simulation or in video, I will also inform you about this. Distributor is something which will distribute the air, or it will deliver the air with the same pressure. From, say, distributor may have 4 ports, it may have 5 6 like that. So from any of the ports, if you are supplying the air, so it is just there. Most of the times you people might be knowing FLR circuit, that is filter lubricator rectifier circuit. So through that circuit we are getting air. That air is supplied firstly to the distributor, and then through distributor, the name itself suggests you, distributor, it distributes there. So it will be distributing air through its ports with equal pressure. That is the job of distributor. So that is how we can indicate the distributor. So it has always got only and only one inlet connection. Then there is 4-way, 5-port, single inlet dual exhaust. So this is another possible position over here. We can say that at the start of the cycle it is started, and then removal is also there. So these are all very important symbols. Once we finish with this, I will also forward this PPT immediately to you. Now these are the symbols for valve actuators. So what does it mean? That is spring actuated. Mean inbuilt here. If you go through the cross-sectional features, you will understand. Then there is manual. Manual means something like a push button, or there may be some other arrangement possible. That is lever kind of arrangements are also there, or simply a plain surface is provided like manual. You just push it over there. Push button arrangements are there like buttons, then levers are there. Mechanical means there is roller attached at the end of the wall. So if you are pressing that roller, it will be, so they actually it is not indicated. There is one spring attached to the roller. So if you are pressing the roller, spring will allow air to pass through from one port to another port. Otherwise, it will keep it in the block position. Then there is a solenoid valve. Solenoid valve, solenoid you people might have studied in maybe second year in the basics of electrical engineering probably. So solenoid you people might be aware, it is electrically activated element. So if you are passing through electricity, so it will be able to create um, actuation. So that electrical actuation also you need to keep it in mind. Then there is air pilot. Anybody is having any idea about this air pilot? What pilot connections are there? Air pilot means dotted lines are only indicated. What does it mean? There is another detent kind of mechanism is also there for actuating the valves. But this air pilot, huh?
Outlet port of any valve.
Uh, okay. Anybody else? See, you might have heard about this word pilot operated valves. So pilot operated sometimes, as you said just now, that is outlet port. So it is not most of the times not directly connected, but it is controlling through some other means. Some in between there is some other connections are possible, and then directly it is not. Suppose you are having one 5x2 wall and one 2x2 wall. In between that you are placing 3x2 wall. So with 2x2 you are controlling 5x2, but not directly connected to 5 by 2. So 2 by 2 will get connected to 3 by 2 and 3 by 2 will get connected to 5 by 2. So 2 by 2 is actually running 5 by 2, but not directly. So that is obviously occurring with the exhaust port of the wall. So this is air pilot is possible. So this is how different positions can be indicated. These are actually the different means of actuation. Actuators will get actuated. And this is what another important thing. So all types of walls, I see whenever there is question regarding the walls, this is how you will have to explain it. There are different types of directional control wall. There are check walls, restriction wall, and control wall. So first is check wall. Check wall indicates allows a flow in one direction, but blocks the flow in other direction. Now in this example, flow can go from right to left, but not from left to right. It is blocked. So the position of the arrow indicates. So you can say that this particular arrow indicating divergent portion from left to right. So it is allowed to pass through. And from left to right, you are getting convergent portion. So it is not allowing in that direction. There is fixed restriction or orifice. So it restricts flow in both directions. Then there is adjustable restriction. It restricts flow in both the directions. And there is flow control wall. Now in this flow control wall, also called spill control wall, it allows free flow in one direction but restrict flow in the other direction. In this example, free flow is from right to left and restricted from left to right. So it is similar thing. Only addition with this wall is the restriction or orifice kind of facility. So pressure or flow of air is adjusted as per your requirement. Because this is what the necessity is there in industrial applications. Wherever you are going to apply it, you don't require uniform speed most of the times. You require variations in speed. So as per your requirement, it can be adjusted with the help of this wall orifice. And this is the last wall. You just observe this wall. By that time I will put the attendance link. So I put the link for your attendance. Omkar, what happened? Omkar now joined.
Oh, no, sir.
So this is you can call this as shuttle wall. So description is there for this wall, that is, it is 3-port wall with 2 inlets and 1 outlet. We can see 2 inlets as per the direction of arrow. We are not familiar with that. So in this example, port 1, 2 are inlet and port 3 is outlet. If pressure is applied to port 1, it will appear out port 3, but will not backflow from out from port 2. So this kind of arrangement you require sometimes. If pressure is applied to port 2, it will appear out from port 3 and it will not backflow from port 1. And when the pressures are removed from ports 1 and 2, port 3 will exhaust back out one of the two inlet port, but it may exhaust out either of them. So this kind of arrangement, whenever is the requirement. Shuttle means you already might have observed, this is something like pressure relief situation. If you want to create, this particular wall is used, that is shuttle wall. So this is all as per as the symbols of the walls and actuators are concerned. We will directly try with the circuits or start with the circuits next time. Okay, I will upload this PPT for your people reference. Okay. So you can just register your attendance. If any doubt is there, just mention over there. We will discuss it next time. Okay, thank you then.